Okay, so let's start.
So what happened to you decided on doing model 5? That's
Yeah.
what you said you wanted to do that.
Yeah, no, you come here, we finish this one doing that. I want to do that. So, we are looking at page 123, module 5, sketching graphs. Right? So, you all have done determinants, you all have done complex numbers, you all have done. Okay, they call this module 5, but it's actually module 4. Right? Their module 1 starts with equations, manipulations, right? So this is actually module 4 in terms of your syllabus. Right? So you all did determinants, you all did complex numbers, you all did trig, and then now we're on graphs. Okay? It's not a very difficult section. It's just that in terms of the graphs, the amount of graphs you'll need to know and the formulas, that's a bit difficult. Not difficult, a lot to remember. Right? So let's get into it. I'm on page 124.
Going back to this thing of ax plus by.
Yeah, your formulas for graphs, right? So you're going to learn about a straight line graph. You're going to know an ellipse graph, circle, parabola, hyperbola, tan, trig graphs, and then you're going to do log graphs, right? Exponential graphs. So you need to know all those graphs, right? Okay, so I'm on page 124, right? Coordinates. Any point on a graph can be described by an ordered number pair, and that's obviously your coordinate. Your x value is written first, your y value is written after, okay? These are called your coordinates, okay, and then they tell you x is known as your abscus and y is known as your ordinate. For example, they give you a, at point A, it's 2 and 3, right? Which would be your x-intercept then? 2, and your y-intercept? 3, okay? So, okay, that's basically, you know what's coordinates, right? Let's look at domain and range. So, consider the set of ordered number pairs where they tell you the set is equal to 1 and 1, 2 and 4, and 3 and 8, okay? The set of x coordinates is known as your domain. So, I can highlight that, right? So, domain is your set of x coordinates or your values for the x coordinates. Okay, so for this set that we have, what would be your domain?
1, 2, and 3.
1, 2, and 3 is all your values for x. So that set they gave you was, what it was, 1 and?
1 and 1.
1 and 1?
2 and 4. 3 and 8.
4 and 3 and 8. So we said domain is your x coordinates. So for this example here, your domain would have been 1, 2, and 3. All your x values, right? Now, domain is all your x values, range is all your y values. So your range is your so for this one over here, what would be your range? 1, 4, 8. Okay? You need to know all these things I'm going to discuss now, because in terms of how they test you, they make you draw a graph or something, right? From the graphs we're going to look at later. And then they're going to ask you, what is the range of the graph? What is the domain? They're going to ask you about, is it continuous, discontinuous, relative, function graph, all that stuff. And we're going to go through that now. So, that's that. Dependent and independent variables. How many of y'all know what dependent and independent variables are? Okay. In the equation or formula, A is equal to pi r squared. Right? We all know this formula. Right? A is equal to pi r squared. It's the area of a circle formula. Right? We're using that as the example. Which would be your dependent and which would be your independent variable? Right? As the name would suggest, if something is dependent, it means it's depending on something else. Independent means it can stand by itself. Right? So in this equation, A is dependent on the value of r. Because for every value of r, you will get a different value of A in this equation. Right? So this now will become a dependent variable, because the value of this is dependent on the value of your independent variable, which should be r. In this equation, independent variable, it does not depend on anything else. There will be a set value for your radius. Agree? You understand what I'm saying? Okay? But this value here is dependent on what this value is. You understand it?
So why can't pi be independent? Because
Pi is a constant.
Because it's what I'm saying. It's not dependent on anything.
But it's a constant.
Okay.
The value is not going to change. Pi will always be 3,14 blah 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 blah. Right? R could change, but that's circumstance dependent, right? On if you got a bigger circle or something like that. And then from this formula, your dependent variable is A because it's dependent on R. R will be a value that you will have from your information. You will substitute it into this formula and it will give you your area. So this will be your okay. So what do they tell you there? If you called A is dependent, if you choose value of R. Okay, so if we manipulate the formula, the same formula here, and make it the subject of R, R would be equal to A pi and the square root of that, right? Okay, now what would be your dependent and what would be your independent variable?
What is the dependent?
R would now become your dependent. You'll understand that? Because R will now be dependent on the value of A. A would be an independent value because you're substituting that into your formula. So in this instance here, this would now be your dependent, and that would be your okay. So generally you can say that if you have a formula equal to something, to a one variable, whatever it's equal to, that variable would be your dependent, and whatever variable is in the equation would be your independent. Okay? Okay, if you look at the formula where they tell you S is equal to half GT squared. So if they tell you S is equal to half GT squared, it's one of the formulas we use in science, right?
Yeah.
What would be your dependent variable here?
S.
S, because S is dependent on what? Time is. G is a constant, it's a gravity, right?
Yeah.
So your independent would be time, your dependent would be S. Okay, we're okay with that, right? So now we know what your domain is, we know what your range is, we know what's dependent, we know what's independent. Okay. Now we're looking at functions and relations. So if the relation between two variables where one is dependent on the other, for example, the one where we had A is equal to pi r squared, the dependent is said to be a function of the independent variable. Okay? What they're saying is that the dependent variable is a function of the independent variable. So for this example, your area, which is your dependent variable, is a function of the radius, which is the independent variable. Okay? And then as they continue saying that, they'll say in A is equal to pi r squared, A is the function of r and can be written as follows. Okay? Okay, right? A is equal to pi r squared. Okay? It can be written as follows. The function of the radius is equal to pi r squared. Okay? Your dependent variable is a function of your independent variable. So the function of the radius is equal to pi r squared. Understand?
Yeah, now we got a see, now we got a new equation.
But this is basically the same thing as that. It's all we're saying is that it's a function of the radius, and the function of the radius from this formula would be your area. Okay? I'm sure at some point you saw f of x is equal to. That basically means the function of x is equal to the formula. That function of x is your y values.
Yeah, I remember that one.
Okay. So, yeah, they got that. Another example is y is equal to sine x. So y would be a function of the value of x, right? Therefore, f of x is equal to sine of x, or g of x is equal to sine of x. You could sometimes use f, sometimes use g. If they got two equations, and if you're working with two equations, they call one f of x, they call one g of x. Okay, but both mean the same thing. It's a function of the independent variable. Do we understand that? Everybody understand that?
Yeah.
Okay. Right. The distinction between a function and a relation can be explained as follows. Now, this is important, right? If the relation between an x and y value is such that when a value of x is allocated, you only obtain one value of y. Highlight that, right? Y is said to be a function of x. So, when they ask you in the test, is this graph a function or a relation graph? If you substitute a value of x and you only get one y value, it is a function graph.
Okay.
Understand what I'm saying? Not difficult, right? It'll give you an equation, right? And if you substitute a value for x and you only obtain one value of y, that basically means that it's a function graph. If you substitute a value of x and more than one value of y is obtained, it is now a relation graph. Okay, you can highlight the bottom part after that. Okay, can I take this up? I'm gonna explain what I mean then, right? Say for example you have this equation that they give you, y is equal to 2x, right? If you substitute a value of 1 for x, what would be your y value? 2, right? If you substitute a value of 2, if you substitute a value of 3, you're going to end up with 6. So you can see that there's only one y value that was obtained for every value of x. Okay? This is function, right? And we said for every value of x where more than one value of y is obtained, that would be a relation. So for the example, let's say y is equal to the square root of x.
No, it's more than plus minus.
Right? So for every value of x, if we substitute 1 for x, square root of 1 is what?
1. Plus minus.
Plus minus 1, right? So you end up with a value of plus 1 minus 1, right? If I substitute a value of 2, okay, let's not take that number. I'm not going to calculate again. Let's take a value of 4, right? The square root of 4 is what?
Plus minus 2.
Plus minus 2. It could be positive 2, it could be negative 2. If you substitute it back, obviously you're going to end up with that same thing, right? If you square 2, it's what?
4.
If you square negative 2, it's
4.
4, right? If I had to say 9, what number are you going to end up with?
Plus minus 3.
Plus 3 minus 3. So you see that for one value of x, you obtain 2 values of y. So what this means is that it's a relation graph. Okay? Okay, so now they tell you that I'm on page 126, right, halfway through the page. Graphically, this can be represented as follows. Now, y is equal to 2x is basically a straight line, right? So, it's a straight line. You can see how you can look at it in terms of a graph is, see this y is equal to 2x, right? The graph will look something like this. Just saying, for example, let me start here. Yeah, this is your y-axis, that's your x-axis, right? It's a straight line graph, okay? When you're looking at it graphically, if they gave you this graph and they never give you the values, and from what we said, a function graph is for every value of x, you only obtain one value of y. So, let's just say I'm taking an x value from here. How many values of y obtained?
1.
1. If I take it somewhere here, how many values of y obtained? 1. Right? So, visually looking at the graph, you can tell that it's a function graph. Because for every value of x, when it cuts this, you're only obtaining one value of y. Okay. Now for the y is equal to square root of x, that's more of a parabola graph, right? So y-axis, x-axis. So let's just say the graph looks something like this. Horizontal. So let's say the graph looks something like this, right? Now we said for a relation graph, for every value of x, you obtain more than one y value. So let's just say if I'm taking a value of x here, and if I'm going to the graph, isn't I'm also obtaining a value of y here? Right? So now I obtain how many y values from one value of x? 2. So even if you look at it like somewhere here, okay, I obtained 2 values of y for one value of x. So looking at a graph, you can also tell whether it is functional or relational. Do we understand it?
Yeah.
Okay, cool. So now you know what's domain, you know what's range, you know what's dependent variables, independent variables, you know function graphs, you know relation. Got it? Okay. Let's look at writing some equations as a function of. Okay, remember I told you like if I said y is equal to 2x, if you're writing it as a function of x, you would say f of x is equal to 2x, right? So if I have the equation y is equal to 3x plus 2, right? Write it in terms of functioning, in the function of the independent variable. So what you will do first, you will obviously need to identify what's your dependent, what is your independent. So your dependent variable here is y, and your independent x, right? And when we write it in terms of function, we say the function of the independent variable is equal to, and then it will be equal to the equation, right? Okay, now if you're substituting values for it, like just say for example they want to know what is x equal to 2, what will be the value, okay? You can write it as the function of 2 is equal to 3 times 2 plus 2, which is 8, right? 3 and 2 is 6 plus 2 is 8. Okay, so that sometimes they can even ask you like that. Let's say f of x is equal to this equation, calculate the value of f, open bracket, 2, close bracket. All that basically means is for every value of x, substitute the value that they gave you here. So, another example, if they gave you two x squared minus 1, right? The function of x is equal to 2x squared minus 1, right? What happens if they ask you for g of x plus 2? What will you do?
So when there's x, we'll
Substitute x plus
Right? So when there's x, you will substitute x plus 2. So you will say 2 times x plus 2 all squared minus 1. You understand that? Okay. Then you will just work out your bracket as normal. So 2 into, so this here remember is going to become, it's going to be 2 brackets, right? X plus 2, x plus 2. So it will end up with x squared plus 4x plus 4, right? Minus 1. You end up with 2x squared 8x plus 8 minus 1, which is 2x squared plus 8x plus 7. So for the function of x plus 2, it will be equal to 2x squared plus 8x plus 7. Understand? Right? Okay. Now you know what f of x looks like, what g of x looks like. It's all basically the function of your independent variable. Right. Now I'm looking at page 128. I'm looking at the inverse. Okay. The inverse of functions and relations. So, ready, right? Okay. If we switch all the x and y coordinates, we will obtain the inverse of a relation or a function. So when they ask you for the inverse, what you're basically doing, swapping all your x and y coordinates. So where you would have an x value or x and y value, you would swap it, right? So we indicate the function with f or a, right? So okay, can I take this up? Okay, now that's it. Okay. So remember when we say a function, we indicate it with f, and then we'll say f of the independent variable, right? So this will be used to indicate a function. To indicate an inverse function, we would say f to the minus 1. So this is inverse function. Okay. Then they tell you, what do they tell you? Okay, so they tell you if a is equal to those coordinates, right? A to the minus 1, which is the inverse of that, you see they just basically swap the x and the y value. So in your first bracket you had 1 and 3. They swapped it and it became 3 and 1. Simple, right?
Yeah.
Okay. Now, if you have an equation, can you tell me what the f of x is equal to?
2x plus 3.
2x plus 3. And they want you to show basically your inverse. How would you show it? Right? We know that the function of the equation will be written as y is equal to 2x plus 3. Agreed?
Yes.
Everybody understands why I got this, right?
Right.
Fair. What did I say for inverse? What you would do?
Swap for x for y.
Swap your x and y. So for the inverse, you would say x is equal to 2y plus 3. And then we make y the subject of the formula. So this would become what? X minus 3 is equal to 2y. And then x minus 3 all over 2 is equal to y. Therefore, f x is equal to x minus 3 all over 2. The inverse function of the independent variable is equal to x minus 3 all over 2. You understand that? Anybody confused? Basically, once whatever I got, where I got y now, remember this y here will represent the inverse function. So this here basically means the inverse function of the independent variable is equal to that equation. Understand?
Yeah.
Okay. What? I feel like you gotta say it. Say it.
No, I'm trying to grab it.
It's not bad, it's just you swapped your x and y, you made y the subject of the formula, and then remember y is normally written in terms of your independent variable, say the function of the independent variable. Because that's an inverse graph, you have f of minus 1. These terms I need to know now, so later on get into graphs, you'll understand.
see, I thought when you were writing the last step, it was gonna be the inverse function of y is equal to x minus 3 over 2.
Yeah, you thought inverse function of y. No, but remember when we write in terms of functions, we write in terms of the independent variable. Now, if you're looking at this equation, which is a dependent, which is an independent?
Y is dependent.
Y is dependent on this value of x, which makes this here your independent. And when we're writing in terms of a function, we write the function of the independent variable. Okay, always remember that it's a function of the independent variable. And like I said, whatever it's equal to, if whatever you have there, you normally write that as the function. You would say function of whatever independent variable is there. It's not difficult, right? It's okay for now. It's gonna get difficult. Please now you'll know not. It doesn't surprise you all anymore, right?
No, yeah.
Guys, for maths and science, I suggest if you're learning for the exam, start learning from now. You know, in terms of the rules, you'll need to know the formulas, that sort of thing. And the way you learn it is by actually doing it, right? Because the more you do it, you will get harder at it. It's like when you're into work and you'll work with the same piece of machinery for years and years and years. Even if you're good now, it'll still be in your head. It's the exact same thing with this. The more you do, you get stuck in your head. Right? So they tell you over there on page 128, about like halfway through the page, it is not always obvious that a relation or a function is the inverse of another function. Right? So what they're basically saying is, I know that if you all think that this here is the function graph, the inverse function will look like that, or it will look like that or something, right? That's not always the case, okay? Because, see, if you look at the graph that they show you over there, they show you y is equal to 2x plus 3, which was our function graph. Can you see how it goes? And where it is, right? It's moving from your first quadrant sort of through your second into your third quadrant, right? But if you look at the inverse graph, where y is equal to x over 2 minus 3 over 2, can you see how that graph looks? It's not always obvious that you can see whether it's an inverse of another graph. But if in terms of the parabola graph you'll see on the next page, you can sort of tell that that is an inverse, right? And in terms of the graph that's in the bottom of page 129, that day you can look at it and tell which is the inverse and which is your function. Agreed? What?
A relation is a function, is an inverse graph. Exactly.
No. Remember, relation we said is if the one value of x cuts two y values, right? So they're saying a relation or a function is not always, it doesn't always look the same as the inverse or the opposite, right? For the first two examples that they give you, the y is equal to 2x plus 3, and then the one below that. So figure 5.6a and figure 5.6b. Can you see those two graphs don't look exactly the same, or it doesn't look flipped over or opposite or something, right? But then if you look at figure 5.7a and 5.7b, it's basically turned to the side. But that is an inverse. 5.7b is the inverse of a. Right? So it's not always evident that you're going to see the exact same thing, like a flipped version of it or something. But if you look at 5.8, the line going up to the right, that's one equation. The line going down is the inverse. That looks like an actual inverse of something, right?
Okay.
So don't always think that whenever you're drawing an inverse of something, it's going to look like a flipped image or mirror image or something like that. That's not always the case. And understand that, right? Okay. So I want you to attempt the inverse of y is equal to x plus 4. Y is equal to x plus 4. Show me the inverse. Can you take this over? Don't look at the answer. You got it? I did it. Okay. So looking at this then, your function will be written as y is equal to x plus 4. Eh? So for the inverse of it, you would do what? Swap your x and y. So you would say x is equal to y minus 4. Then this is the graph.
Yes.
Y minus y plus.
Y minus y plus 4.
Plus 4. Plus 4.
Oh, sorry. Right. Now I'm going to take something to look careful. I'm going to come back to that. Okay. Then you make y the subject of the formula. Right? So therefore, y would be equal to x minus 4.
Yeah.
So your functional part will look like, your inversely function will be f of minus 1x is equal to x minus 4. That would be your inverse. Not difficult. Right? Cool.
So why do they say if the inverse and then y is equal to x minus 4?
So they're basically saying your function is equal to this equation, and then here they're saying the inverse function and they're writing it on fully.
Same with that one, sir.
Yeah. No, here when you say it as f of minus 1 of your independent variable, they just don't want to call it that because it's going to confuse you as you.
Okay, but that's how we should answer it.
Yeah, your final answer should be here. No, nice. I'm nobody pays for it. But if they're fixing windows, they must fix where our aircon pipe is. Right, that's fine, okay? Now I'm on page 130, continuous and discontinuous functions or relations, okay? So, continuous means without interruption, meaning it will just continue, right? And obviously discontinuous would mean where there is an interruption, right? So, if there is an interruption at a certain point in a graph, the function or relations become discontinuous at that point. Example the following graphs. So your first graph in 5.9a, you have y is equal to x plus 2. Straight line graph, you can see the graph is going up, right? Then in the next graph, you have the formula of y is equal to x squared minus 4 all over x minus 2. The two graphs are identical in how they look, except for point 2 and 4. Right? So your x-intercept is equal to 2, your y-intercept is equal to 4. Which is not defined for y is equal to x squared minus 4 all over x minus 2. Can somebody tell me why that two graphs are different at that point where your x value is equal to 2? Can somebody tell me why the graph in figure 5.9a is different from 5.9b at x is equal to 2?
Because of the x squared.
Yeah, tell me more.
Say 2 times 2, that's 4, minus 4 is 0. So
Is 0, right? So, if you have to substitute that x value into that second graph equation, Right? If you, so that second graph equation, so the first one was y is equal to x plus 2, right? That was graph 1. And this one here was equal to y is equal to x squared minus 4.
Yeah.
All over
X minus 2.
x minus 2, right? So we said at the point when x is equal to 2, these graphs are different, right? Why is it different? If you substitute 2 here, it will be 2 plus 2, you get a y-intercept of 4. If you substitute 2 here, 2 squared is 4 minus 4 is 0. 2 minus 2 is 0, right? You're not going to get a point. 2, anything over 0 will be what? Undefined, right? You're not going to get a point at all. It's not going to be 0. Anything over 0 is undefined. 0 over anything is 0. Okay, but anything divided by 0 is undefined, so there will be nothing there. So, what does that mean? That means that the second graph is discontinuous at x is equal to 2. Do you understand? Because remember the first graph, for any value you substitute for x, you're going to obtain a y value, right? Okay?
Yeah.
So the graph is continuous because you are getting a y-intercept. But for this graph here, even if you substitute minus 2 plus 2, you still get a y value of 0. That's still a point on the Cartesian plane that it can cut through. So this graph can carry on until infinity, because for every value of x you substitute, you are getting a value, right? This graph here, when you are drawing it, you're going to draw it and you're going to end up with a break somewhere, and then it will continue. There'll be a break at a point. And that point would be x is equal to 2. That makes it discontinuous. Do you understand what I'm saying? Is everybody okay?
Yeah.
Okay, so you can say that the graph is discontinuous at a point x is equal to 2 for these equations. Understand? Okay. Okay, so don't worry about limits discussed in module 6. I'm on the part where it says, for the purpose of this course, this means that you may not divide by 0, or the limit may not strive to infinity. That's the 2 points you need to know on when you are deciding whether a graph at a point is continuous or discontinuous. Right? The first condition is that you may not divide by 0, and the other point is the limit may not strive to infinity. Okay, that's the 2 conditions in each other. If they give you the conditions of the graph, and if they tell you the graph lies between negative infinity and positive infinity, right? They're basically telling you that this graph will continue until infinity and negative infinity. So it's continuous always. If they give you this condition, the entire graph is continuous, right? If they don't give you this condition, and if they give you a limit to it, like if they tell you the graph lies between minus 10 and 10, you know that the entire graph is discontinuous. Why? Because it's going to stop at a certain point. Okay? Another thing is, if they're looking at certain points, you see here in the question, if they ask you, is the graph, I'm not writing the whole thing, right? Is the graph continuous or discontinuous at x is equal to 2? For this graph here, y is equal to x plus 2, is it continuous or discontinuous at x is equal to 2? What you'll do, you'll substitute 2 over there. You substitute it, you get a value of y, right? So it's continuous. Then if they ask you, is the graph of y is equal to x squared minus 4 all over x minus 2 continuous or discontinuous at a point of x is equal to 2? What you will do, you will substitute it in that x-intercept into your denominator. 2 minus 2 is 0. What's the condition? You may not divide by 0. That will make this graph discontinuous. So it's discontinuous at a point of x is equal to 2. Do you understand that? Okay. So now you'll know domain, you'll know range, you'll know what is it? Yeah, dependent, independent, functions, relations, inverse graphs, and you'll know continuous and discontinuous graphs. You know that? Everybody knows that.
Yes.
Cool.
I don't know the independent.
Independent and dependent variables.
Yes.
So what we said was dependent and independent variables. You can say, for example, you have this equation here. Dependent generally means that it's dependent on something else, right? Something else has to happen for this to happen. Independent means it can stand by itself, it doesn't need anything else to happen. So in terms of this equation, this value of y is dependent on the value of x, right? But this value of x is not dependent on the value of y in this equation, because you will just have a value that you would substitute into this and you will get a value of y. So this would make it dependent and this would make it independent, right? Okay, but now if I to swap it and if I to say x is equal to y minus 2, which should be your dependent, which should be your independent?
X will be dependent and then y will be
Independent, because your x value is now dependent on the value of y.
Yeah.
Okay, and that's why when we came to this here, when we were writing functions of, right? When you're writing a function of something, you write it as the function of your independent variable. So if you have to write this as a function, which is your dependent, which is your independent?
on that.
On this one.
Okay, y is dependent.
Dependent, right? That means x is your independent. So when you're writing a function of something, you will write it as the function of your independent variable. So you will just basically replace your dependent variable is equal to and then whatever the equation was. Okay, so that's that. Okay, so now we know quite a bit about graphs, right? Symmetry, right? Symmetry means that one part of the graph with respect to an axis or a line forms a mirror image with another part of a graph. Okay, if you look at the next page, you can basically see that it's symmetrical about your y-axis. So everything on the left hand side of the y-axis would be a mirror image on your right hand side of the axis. Can you see that? Right? And when they tell you A is symmetrical to B, we can also express this in tabular form. So if you look at your values of x, right, as it goes -4, -3, -2, -1, 0, 1, 2, 3, 4. And if you look at your values of y, can you see how the same increments or that it's decreased by or increased by is the same that after 0, no, sorry. The same increments before 0 it increased by is the same increments after 0 that it increased by. Okay, you can see that, right? Okay, so that's basically how you would identify symmetrical ones. So that's very straightforward, right? You'll just look at it at a certain point, you'll have your values as equal to each other, and then as you move up, it will basically be the reverse on the other side or the opposite. Okay, so that's basically the that's basically your things that you need to know by looking at a graph or identifying it, because they do ask you this, right? Before I get into the main things about graph, like sketching graphs, then in an exam they'll ask you to sketch a graph, which is what we're going to do next, right? But then from there they'll ask you, is the graph a function or a relation? Now how would you identify that? How do you know whether a graph is a function or a relation?
One value of x is giving you
A function is for every value of x you obtain one value of y. A relation is for every value of x you obtain more than one, right? They'll ask you, is the graph continuous or discontinuous? Now what you would do there, if they ask you at a point, you just substitute that point in the denominator. If you end up with 0, it's going to be discontinuous because you can't divide by 0. If it gives you a value for it, the graph is continuous. They'll ask you what is the range of the graph. They'll ask you what is the domain of the graph. Okay, so all this is important marks. It's like 1 or 2 marks each part. If I ask you like 4 or 5 questions on that, then 1 or 2 marks could be like 5 or 10 marks. Right? Simple things that you can do. Okay. Let's look at exercise 5.1. Can I take on, sir?
Yeah.
Okay, exercise 5.1. Number 1.1. Right? So they ask you first to calculate the domain. What is domain?
The X.
All your x values. Right? So what should be the domain of this? 1 to 3. Then they ask you for the range. What should be the range of this? 2, 4, 6. Then they ask you for the inverse. What should be the inverse?
2 to 1.
What you do for inverse, you just swap x and y values. So this would be 2 and 1, 4 and 2,
6 and 3.
6 and 3. Easy, right? Then, let's do it with alphabets. Right? If they tell you these equations here, A and E, B and a minus C, D and F. Right? What should be the range of this?
E minus C and F.
Oh, sorry, I thought to be the domain. Sorry, I was supposed to ask this. Right? It would be A, B, D. All your x values, your x coordinates, right? Your range would be
E minus C
F. What should be the inverse?
EA minus C
minus
D.
C
F is
F D.
You're doing it faster than I can, right? Okay. Now they give you something like this. The way they wrote it, you see how they have x, y all over y? That's also a way to write the function of something. You know, like f of x, g of x and stuff? That's also the way to say a function of it. Okay? But they very rarely write it like that. They normally write it as f of x or g of x. Okay? They gave you this, right? What would be the domain of this? Okay, what is domain?
Oh, your X.
All your x values. From the condition they gave you, what are they telling you? Your x lies between 0 and 3. So what would be your domain? No, it's not minus a thing. It basically is telling you that your first x value will be at 0, your last x value will be at 3. So all your values of x will lie between 0 and 3. So your domain of it would be 0 less than x less than 3. Okay? And understand what I'm saying, right?
Yeah.
Okay, all the values for x that you would substitute would be between 0 and 3.
Because they're telling us what the domain
They told you what the domain is, right? Now, B, what would be the range of it? How would you get your range for this?
Let me solve.
You'll substitute this 0 into the equation first, right? 2 times 0 is minus 4, right? So y is equal to minus 4 less than y less than, and then you substitute 3. 2 times 3 is 6 minus 4, 2. That will be your range for it. Okay, so all your values of y would lie between minus 4 and 2. We all okay with that? Anybody confused?
I'll call it once. Can you redo it again?
They do it. Okay, so they gave you this equation, they gave you this condition. We want to know what's the domain. Now, domain is all your x values. For this graph, they're telling you that your x values will all be between 0 and 3. So it's not going to go less than 0, it's not going to go more than 3. Because that is your condition, that is where it's between, like a parameter sort of, right? So, if they're telling you all your x values will lie between 0 and 3, your domain of it would be 0 less than x less than 3. It's going to be all the values that lie between 0 and 3. Do you understand what I'm saying?
So if you answer 0, 1, 2, and 3.
No, but then what about like if they're depending on what increments or something they're looking at? What if they're looking at 1.5, 2, 2.5? So this here basically covers every single point to be from 0 to 3.
Okay.
Right? You're okay with that?
Yeah.
Okay.
Then for your range, right? Your range is all the possible y values. Now remember, for every x value there will be a corresponding y value because of the equation.
Right.
So for your minimum x would be 0. You understand what I'm saying?
Yeah.
The lowest value that x could be would be 0. So you substitute in here to get your lowest y value that it could be, which would be -4, because we just substituted it there. And then the highest possible x you could get is 3. So you substitute there to get the highest possible y. And every value for y after that would lie between -4 and 2. Right? Okay. Then they ask you for the inverse of the graph. They ask you for the inverse.
Yeah.
The inverse of the graph. How would you do it? So we know our equation. Okay, so the function is y is equal to 2x minus 4. For inverse, what do? You swap your x and y. That will be x equal to 2y minus 4. Make y the subject of the formula. You end up with x minus 4 all over 2 is equal to y. Therefore, the inverse function of x is equal to x minus 4 all over 2. It's okay.
X plus 4.
Yeah, you're right. Because if you take it across, become plus, divided by 2. Right? Do you understand?
Yeah.
Not bad. You want to do one more example again?
Yeah.
Okay. You got 1.4. Can I take a okay, now let's see.
Yeah, let's see if inverse it's still gonna be a little bit of a problem. It's f minus 1x is equal to x.
It's the function of the independent variable. Just say it in your head one way. The function of the independent variable will be equal to the equation. You're just basically replacing the dependent variable and saying the function of. You'll see this more in derivatives. Right?
Oh, I hated those days.
Ooh. Okay, what's this equation? It's half x. What's 1.4? Half x
Plus 2.
plus 2.
Minus,
The condition?
minus 2.
Less than x.
And more than
Less
2.
than
Yeah, less than 2.
Okay. So, how would we do this, guys?
Okay, so let's
It's less than equal to 2.
less than equal to
What is the domain?
A minus 2 and
Minus 2 less than x less than equal to 2. Because they're telling you that x will lie between minus 2 and
or equal to
or equal to 2.
Yeah.
That could be the everything in between those and including 2 would be the values of x. Right? The range. How would you get your range? So substitute these values. So minus 2, so half times minus 2 is
1.
minus 1. Plus 2,
1.
1. Less than y, less than equal to, half times 2, 1, plus 3, plus 2, 3. Right? That will be your range. We understand that? We all understand that?
Yes.
Okay. Now for the inverse, right? We know the function of this is y is equal to half x plus 2. Your inverse of the function will be, you just swap the x and y. So this will be x equal to half y plus 2. Make y the subject of the formula. You end up with x minus 2 equal to half y. Multiply by 2 here, you get 2x minus 4 equal to y. Therefore, the inverse function of the independent variable is equal to 2x minus 4. Are we okay? Everybody understand? Okay. Do you want to take down anything? Okay, question 2. They ask you to determine if the function, determine whether the following are a function or a relation, right? So, what's a function? I'm gonna keep on making you say it until you understand. Right? For every value of x, you get one value of y. A relation would be for every value of x, you get more than one value of y. So, if you look at your values of x here, okay, you have your x value 1, 2, 3. How many values of y do you have?
3.
No. I mean for each value of x, how many values? You get 1, right? So instantly you know that this is a function. Now, they give you 1, right? Look at your values of x. Right? How many values of x you have then?
1, 2, 3.
You have 3, right? It's 3 values because 1 is repeated. Right? It's 3 values, 1, 2 and 3. But look at the value of x equal to 1. How many values of y do you have?
2.
You have value 4 and you have value 5. So for one value of x, you got 2 values for y. What does that mean? It's a relation.
So can you repeat it? Why it's repeated?
Huh?
Say it's repeated.
No. So remember, I said that for a relation, for every value of x, you have more than one value of y. Remember, you read, I'm making mistakes. Right. So if you look at your x values you have is 1, 2, and 3. No, yeah, 1, 2, 3. Right? Then if you look at your y value, for a value of 1, you have 4. For a value of 2, you have 8. For a value of 1, again, you have 5. For a value of 3, you have 7. So these here are just for one value. But this one, for one value of x, you have 2 values of y. And by the definition, that makes it a relation. Okay. Can I take it? That's it. Yeah? Yeah. You should got that.
Not this one.
This one you should got. Okay. Let me take a look at that. Okay, now I'm on question 3. Right? No, I'm not on question 3. I'm on question 2.3. 2.3, we're still deciding on whether, not deciding, we are still discussing whether the graphs are functions or relations. Right? Now, we looked at it in terms of if they give you the values. Now, in terms of if they give you the graph. And that's the line you're looking at, right? Okay? Determine whether it's a function or a relation. Once again, every value of x, if you have one value of y, it's a function. For every value of x, if you have more than one value of y, it's a relation. So just choose any x value and go up. How many values of y are obtained?
1.
If I go here, how many values of y are obtained?
1.
Right? Even if I come here, I'm still getting 1. So this would be a right. Now they want to know functional relation. Take a value of x. This is my value of x. Going up, I get a y value. But coming down, I also get a y value. If I go here, come here. For one value of x, I got 2, which makes it a
Relation.
If I have this, right? Same story. Choose a value for x, right? Anything, and come up. Okay, the trade off, right? Let's see here. 1 value, right?
Yes.
Okay, here.
1.
So that will make it a function. Because don't look at it and think that because I'm coming here, I'm getting a like 2. It's still 1 by value. If this was -2, It's minus 2 going that way, it's minus 2 coming this way. Eh? Okay.
How can you be minus at the top?
Hey, right? If it was 4. Yeah, I'm stressing too much.
I told you, take
I
a
told you,
break.
take it deeper. What's going on? Right? Okay, 2.6, let's just look at it now, right? 2.6, then the graph on page 134. Looking at it, what can you tell me? 2.6, page 134. Is it a function or a relation?
Same as the top one.
Huh?
Same as the top one.
Same as the top one. You 100% sure. You can bet money on it.
It's a relation.
It's a relation. Choose a value of x in between the chamber.
Yeah,
Draw the lines.
yeah.
Isn't the line can go up and down and get a y value?
Okay.
So you get 2 y values, right?
Yeah.
That's why don't look at it. That's why they gave it to you like that. They gave it to you facing that way. They gave it to you upside down, and then they gave it to you the other side, right? 2.7
It's
Function.
function, right? Choose a value of x, go up to the line, and move towards your y-axis. If you can only move up to your y-axis and get one value, it's it. Right. 2.8.
function.
What is a function?
Relation.
Hey.
It's both
Wait,
the side.
Yeah.
It's the side.
Yeah, it only goes once. Yeah, it's
Choose a
function.
value of x.
Yeah.
Yeah,
Now it goes.
only goes once.
But
No,
you
no.
stop on the y-axis. You know?
Yeah, so you stop on. So it's a
What function?
function.
Yeah.
Right? You choose a value of x, go up or down, either one, right? Wherever you move towards your y-axis, you're still getting one. See, if you, this is 2.7, right? It goes something like that, right?
No, that's 2.8.
You're not remember. Right? Choose a value for x. Let's say I'm taking my value x here. And if I come up, and I come across, I'm still obtaining only one by y value, right? Even though that value of x or this value of y also cuts here, it's still the same y value. If this value is 3, right? So it's still one y value. Only thing you can get it at 2 different x values. But that's not the condition for a relation. Okay? Guys, we all understand that?
Yeah.
That. Okay, take it down and then I'll do that last few.
Husa.
I feel so bad for my extra class. It's like I eat.
You got a go.
Yeah, I couldn't cause extra too.
They're doing in here.
Yeah.
Oh my god, Chefa.
Ow.
It's not my day. It's not my day.
It could be worse.
Mm.
At least Bilal's not sure.
Yeah, Bilal, you heard that? The record, but then you won't even watch the record. Okay. Can I check out? That's it.
Yeah.
Okay, so they asked you in number 3, is y equal to x cubed minus 8 all over x minus 2 continuous at x is equal to 2? What's the conditions I told you for continuous and discontinuous? Or what's the condition for discontinuous?
Must be.
If you can, if you're dividing by 0, or if the limit is not going to infinity, the graph is discontinuous, right? So they asked you, is it continuous at x is equal to 2? So I told you when you're doing that, substitute that x value in the denominator, right? If you substitute it into this denominator, 2 minus 2 is what?
0.
You're dividing by 0, which will make it what?
It's continuous.
Discontinuous, right? So it's discontinuous at x equal to 0. Now, in number 4,
X equal to 2.
it's the same. It's the same equation, but now they're asking you at a point of x equal to 3. Is the graph continuous or discontinuous? So you will substitute this x value in your denominator. 3 minus 2 is 1. So it will be continuous because you're not dividing by 0. Cool. Number 5. They give you x, y is equal to minus 4. Is it continuous at x equal to 0?
It's now for
Okay, so if you make y the subject of the formula, you're going to end up with y is equal to minus 4 over x.
It's gonna be
Now if you substitute it,
discontinuous.
it's going to be 0, which would make it
Discontinuous.
B. They tell you if y is equal to 0. So you'll make x the subject of the formula. You need to see if whatever you're substituting, if you divide by it, is it going to give you 0. So you'll say x is equal to minus 4 over y. Right? You substitute the 0, what's going to happen? You're still going to end up with it.
Discontinuous.
Infinite.
Yeah? You understand that? Everyone. Okay. Number 6. They ask you, your function is y is equal to 4x plus 8. Calculate f of 2. Right?
It's gonna be
So remember that if you write this equation as a function of the independent variable, how would it look? You would say f, what's your independent variable here? How? X, right. F of your independent variable will be equal to 4x plus 8. So when they're saying f of 2, they're basically referring to wherever you see x, put 2. So f of 2 is equal to 4 times 2 plus 8. 4 and 2 is 8 plus 6 plus 8 is 16. What's the next one, Detewa?
inverse.
Okay. So now they want to know the inverse function for a value of 3. So what you need to do? Can I take out the set?
Yeah.
Swap the x and y.
Right? What you need to do? Firstly, you need to get your inverse function, right? So, your inverse function would be, you'd swap your x and y. So you'd say x is equal to 4y plus 8. Then you end up with x minus 8 is equal to 4y. X over 4 minus 2 is equal to y. You understand it, right? Okay. Therefore, f of minus 1, your inverse function would be equal to x over 4 minus 2. You understand this? Right? They asked you for f of the inverse of 3. So wherever the value of x is, you substitute 3. So 3 over 4 minus 2, basically 3/4 minus 2. Yes? 1 1/4. Right? So you can say minus 1 and 1/4, or if you put it in your calculator, they'll tell you minus 5 over 4. Right? Okay. We understand this? Right. Then the last one that they ask you for f of minus 1 equal to 0. So f of minus 1 equal to 0. We know our inverse function formula, right? So wherever you have x, you substitute 0. 0 over 4 minus 2. 0 over any number is 0. Minus 2. That's the answer. So we are okay. Chamba, you got so many pages in front of you, you're writing in your head.
Yeah, I'm so used to this. Even
And it's gone, yeah.
That's something I'm calculating.
Lucky it's a cold day. I'm expecting it's fine after that. Okay. Do we all know what domain is? range,
The range is y.
domain is x values, y is, yeah, okay, thank you. Then dependent value, dependent variables, right? They are not dependent variables. Independent variables, function graphs, whether a graph is function or relation. Yes, you're now to do inverse. You're now to write something as the function of the independent variable, that f of x, right? You're now continuous, discontinuous, symmetry. You went out and
Yeah.
right? But it's not it's just a small point there, right? So that's the theory part of. It's basically that's questions asked on after you draw a graph. Is the graph continuous? Is it relative? All of that. Next thing we're going to look at is actually drawing graphs, sketching graphs.
Because symmetry is like half of it.
A mirror image of it.
Same thing.
So if you draw the graph wrong, then all these answers will be wrong.
Yeah. But you see, what's the good thing is that I showed you how to get all these values from the equations, right? So even if you draw your graph wrong, you'll still be able to get your answers from the equations, right? You'll be able to get your range from the equations, you'll be able to get your domain, you'll be able to see if it's continuous, you'll be able to see, what's the other things? Okay, you all know, right? But yeah, you don't have to look at the graph, but I showed you how to look at it from a graph and get those stuff, and how to look at it from the equation. Okay, can we take a 10-minute break and then we come back and yeah. Okay. Okay, so we looked at how the stuff you can identify from graphs or from the equations given for a graph, right? Now we're on the bottom of page 135, right? And we are looking at sketching graphs. So they tell you at the bottom important information for identifying graphs, and they say the more you know about graphs, the fewer calculations you'll have to do. The following information will help you to identify what type of graph it is. I actually feel like they should have told you all this after they taught you all what graphs is, but anyways, it's okay, right? So, the first point they tell you that the sum or the difference between x and y, if all your exponents are to the power 1, in an equation is always a straight line. Okay? So what they're basically saying is that if you have an equation, for example, let's say x plus y is equal to 2, right? So what we're basically saying is that the sum or the difference, so if you're adding or subtracting of two variables, if they are to the exponent 1, it will be a straight line, right? Okay, what that means, remember exponents is the numbers that are normally found here, right? If it's to the power 1, remember we don't normally show it. So if it's added and it's or subtracted, it's normally the graph you would obtain is a straight line. So it could be straight line, it could be something like that, right? So it's a sort of that y is equal to mx plus c graphs, right? This is in terms of identifying. If they tell you that the product of x and y, so meaning that if you multiply and it's to the power 1, it's a rectangular hyperbola, right? So you can highlight that. On the first point, you can say that the sum and the difference between x and y is a straight line. So the graph obtained would be a straight line graph. On the top of page 136. Okay? On number 2, they tell you the product, so if it's being multiplied. If x and y are being multiplied and it's to the exponent 1, the graph obtained is a rectangular hyperbola, right? You're going to see after I go through the graphs, you'll understand what each of these graphs mean, right? Any exponential equation with the form y is equal to a to the power kx, or a logarithmic equation with the form y is equal to log kx is always one of the following. So the graphs would look something like that. So if you get an exponential graph or a logarithmic graph, that 4 lines there, your graph will always look something like that. Okay, that's in terms of identifying. So if you look at a graph and you see something like any one of these lines, you know that it's a log graph or a exponential graph. Point 4, if you get something that's ax squared plus ay squared equal to c. It's a circular graph with its center at the origin of the axis, meaning that its center would be at 0. Okay? Point 5, if you get a graph where, you see on the top, one above that, you have the same constant, you have a and a being multiplied to x and y in point 4. You see the difference in point 5 is that you have an a value and you have a b value. That graph will be an ellipse. Okay, ellipse is sort of an oval shape. Okay? On the top of page 137, if you have an equation where you have y is equal to ax plus bx plus c, sort of a quadratic formula, if you see a quadratic formula, that graph is going to be a parabola. If your a value is greater than 0, the graph will look like what it looks like. It looks like a U. Right? If your a value is less than 0, the graph will look like an upside down U. That's in terms of the shape. You're all with me, right? Okay. If you have for point 7, if x is equal to, so remember this is the inverse of what we looked at in point 6. Right? They swap the x and the y's. If you have that, and if your a value is greater than 0, the graph will be a U like to the right. Okay? And if your a value is less than 0, it will look like a U to the left. So the inverse of it. You understand what I'm saying? Don't say yeah.
Seeing is believing. We'll see once we get the examples.
Once we do this, but this is what they're giving you rules in terms of identifying what a graph would look like. Okay? Yeah, so I'm on top of page 138 now. So on graphs, the intercepts with the axis are very important. We all know this from school days, is that to calculate the x-intercept, you let y equal to 0. To calculate your y-intercept, you let x equal to 0. Okay. Now, there's about 9 graphs you're going to need to know. So, let's start with the first one. First one is a straight line graph. So,
Always the easiest one.
okay, so this is the straight line graph. Okay, its formula is ax plus by plus c is equal to 0. That's called your general formula. Okay, so whichever formula I give you that's next to the heading of it, that's the general formulas. Okay, then you all normally know it as y is equal to mx plus c. Yes, for a straight line, y is equal to mx plus c, right? That's your gradient formula. M will be your gradient, and then you will work out your points, right? And then x over y plus y, x over a plus y over b equal to 1 is called the intercept form. Okay? So, let's do an example of this. Now you want to basically plot the graph. Right? So, an example of this would be 2x plus 3y equal to 4. Right? This is like how your general formula would look. Right? You got an a value, a b value. If you take this across, it will obviously be a c value. Right? Now you want to plot the graph. To plot the graph, we need to know at least 2 points. How would we get those 2 points? You would work out your intercepts. So, for your x-intercept, you would say let y equal to 0. So you'll substitute. You'll say 2x plus 3 times 0 would equal to 4. Right? So 3 times 0 is 0. So you're left with 2x equal to 4. X is equal to 4 over 2, which is 2. So now you got one coordinate of 2 and 0. Then you want to know the other coordinate. You'll say your y-intercept. And you would let x equal to 0. So this will be 2 times 0 plus 3y is equal to 4. This will become 0. You're left with 3y equal to 4, and y will be equal to 4 over 3. Right? So your other coordinate you have is 0 and 4 over 3. Now you want to draw the graph. So we already know that this is a straight line graph based on looking at the equation. Then this is how the rules from before came. When you add and subtract an equation where the exponents are 1, it will be a straight line. Now you see how the rules are coming, right? So we know our 2 points. The first point we know is 2 and 0. So let's say that's 1, that's 2, right? So 2 and 0, that point will be formed there. Okay? And then 4 over 3 is how many? It's 1.33. 1.33. I think it's 1.3333.
Yeah.
Huh?
Yes.
Yeah, 1.333, right? So, if this is 1.333 is somewhere there, right? And then you will, so this is your y-axis, this is your x-axis, this is the equation 2x plus 3y is equal to 4. That's your graph. Right? So straight line is fairly simple. Okay? If you were given another one where you have y is equal to 2 over 3x plus 1, right? So it's in that form, it's written in the gradient intercept form. So it's still a straight line, right? Y is equal to mx plus c. Same story here. For x-intercept, you would let equal 0. So this would be y is equal to 2 over 3, no sorry, 0 is equal to 2 over 3x plus 1. This would be minus 1 is equal to 2 over 3x, and then you're left with minus 3 over 2 is equal to the value of x. That's one coordinate now. So your one coordinate is minus 3 over 2 and 0. For your y-intercept, you would let x equal to 0. So you would have said y is equal to 2 over 3 times 0 plus 1. Y is equal to 1. So your other coordinate would be 0 and 1. If you were drawing it, your 1 point is minus 3 over 2, which is minus 1.5. Right? So if that's 1 and that's 2, 1.5 is there. Right? Minus 1.5 is there. And your other point is 0 and 1. So your x value is 0, your y value is 1. So your graph would look like that. Understand? Okay? Also, your gradient basically tells you which way your graph is sloping. If you have a positive gradient, it would slope like that. Okay? If you have a negative gradient, it slopes like this. Okay? So if I converted this into the y is equal to mx plus c, right? This would have became this here is 2x plus 3y equal to 4, right? It would have been 3y is equal to minus 2x plus 4. Y is equal to minus 2 over 3x plus 4 over 3. You have a negative gradient. Can you see how your graph is sloping? Positive gradient, it's sloping upwards. Okay, fine.
Gradient is y is equal to, what is the gradient?
For
the gradient, what is the gradient?
gradient is m, right? So this y is equal to mx plus c. So m is your gradient, and sometimes when you work out your gradient, you use the change in y over your change in x. So you say y2 minus y1 all over x2 minus x1. But I'm saying for a negative gradient, your graph would slope like that. For a positive gradient, your graph would slope the other way. Okay? You all okay with straight line graphs? You want to check that in this? So if they gave you that equation and they told you in the test, plot the values for, or plot the graph of 2x plus 3y is equal to 4, you know, looking at the equation, it's a straight line graph, right? You will calculate your x and y intercepts, you will draw the graph. Then if they are to ask you, is the graph continuous or discontinuous? Okay, no, not that. They'll ask you, is the graph function or relation? What is it?
Function.
It's a function, right? For one value of x, you get one value of y. Then they may ask you at a point of x equal to 2, is the graph continuous or discontinuous? You'll substitute the value. If you're dividing by 0, the graph is discontinuous. If you're not dividing by 0, then you're okay. Hopefully they give you a straight line graph in the test. Highly doubt it. But
We hope.
what I noticed they do is, if they give like a difficult question in differentiation, like a very difficult question in differentiation, the other sections they don't, yeah, like the questions are based on weighting. It's level 1 to level 4, level 4 being very difficult, level 1 being simple questions. So if they give like 2 level 4 questions somewhere in the test, the rest are between level 1 and 3.
Okay.
So you can manage with the other ones. Yeah.
Not everything is difficult.
Yeah. But the thing is, knowing which difficult are you going to get. That's the thing. Got it. Can I take out the side?
Yeah.
Okay, so now we're looking at the second type of graphs again, which is your ellipse, right? Its general formula is given by ax squared plus by squared equal to c. Okay, and when you write down all your formulas at the end of this, you'll be able to look at each formula and identify what is different. Because you'll see, you may think that this is similar to a circle one, but you will see a difference just now, right? So this is your ellipse formula. This is the general formula. This is your intercept formula. Okay? It's the same thing, they just rearrange it. Okay. This is your example that you're given. Okay? To plot a graph, we need 2 points. So we would say your x-intercept, let y equal to 0. So 4x squared plus 9 times 0 squared is equal to 36. 4x squared is equal to 36. 36 over 4 is what?
9.
9. Then how are you going to do the square?
Square root.
Square root it. And x is equal to?
3.
Plus or minus 3.
Plus or minus 3. It's 2 values for 3, right? Okay. Now, y-intercept would be let x equal to 0. Right? So you let x equal to 0, you're going to end up with 4 times 0 squared plus 9y squared equal to 36. Right? You're going to end up with 9y squared equal to 36. Y would be equal to 4.
Plus
And
minus.
then you would square root it. Y would be equal to plus minus 2. Right? How many points do you have?
2 points or 4.
You have 4 points. How you have 4 points? Your first point you have is plus 3 and 0. Then you have minus 3 and 0. Then you also have 0 and positive 2. And you have 0 and
-2.
negative 2. So how do we draw this? So if this is your graph, right? This will be 1, 2, 3, 2, 3, minus 1, minus 2, minus 3, 1, minus 2, minus 3. Right? So your first point is positive 3 and 0. So it's there. Second point is minus 3 and 0. This is here. Next point is 0 and positive 2. The last point is 0 and negative 2. Now you join your points. Now remember we said that this is a ellipse. So you're expecting to end up with values like this. And how an ellipse will look, it's not actually a circle, it's more of a oval. I know I'm drawing it looks like a circle because it's not accurate, but if you look at your diagram, right? Can you see the shape of it on figure 5.24?
Yes.
Right? That's an ellipse. Looks like sort of what an oval would look. Right? That was the ellipse. Okay? They give you an example on the next page on how using the intercept form, but it's the same thing, right? But you'll need to be able to look at a formula and identify what type of graph you're going to end up drawing. Understand what I'm saying? If they give you this equation here, you need to look at it and know that, okay, 4x squared plus 9y squared is equal to 36. Then you need to be able to say, okay, it's ax squared plus by squared equal to c. What general formula is that? It's an ellipse. So you know in your head that your graph will look like this and you will come out with 4 points. Okay? Next one we're looking at is a circle. Textbook is so big. So your circle's general formula is ax squared plus ay squared equal to r squared. Or it's x squared plus y squared equal to r squared, or y is equal to plus minus the square root of r squared minus x squared. Okay, that's it. Right? Looking at the general formula for the circle and the general formula for an ellipse. Looks similar, right? What's the difference? The constants are, both are a, right? First your a and b, this one has a and b, that has both of the same constants in front of the x and y, right? And your last value is a squared value. This one here is just a constant that's not being squared. Okay? So that's obviously a difference you need to look at. So, if they give you, for example, 2x squared plus 2y squared equal to 18, right? You now need to work out the values, draw the graph, right? Looking at this, we can tell that it is a circle, right? Because it matches your general formula rule. Okay? So, x-intercept, you let y equal to 0. So, 2x squared plus 2 times 0 squared is equal to 18. X squared is equal to, 2x squared is equal to 18. X squared is equal to 9. You will square root this, you will get x equal to plus minus 3, right? Then you would have y-intercept, you would let x equal to 0, right? Letting that equal to 0, you would say 2 times 0 squared plus 2y squared is equal to 18. So you would end up with 2y squared equal to 18, y squared is equal to 9, y is equal to plus minus 3. So you know your points, right? But you need to write down the points. You know it, right? What our points are for this graph.
Oh.
So, if this is your graph, right? And 1, 2, 3, 1, 2, 3, 3, 3, right? So, 1 point on your x is positive 3 at 0. Another point is negative 3 at 0. On your y, it will be positive 3, 0 and positive 3 and 0 and negative 3. If you connect your points, if it was drawn accurately, you should have a circle. You understand? Okay. Now we're seeing our differences in terms of our formulas. Okay? What else? So far for these formulas, it's straightforward. All you need to do is get an x and y intercept and you can solve. Okay? I don't know what this other example. Can I take out the set?
Okay.
The formula that they all got square root. I mean,
Square.
the square is, so the 18 is not gonna
It's
square.
not a square. If you are to divide by 2 everywhere, right? You're
Okay.
going to end up with x squared plus y squared equal to 9. Right? Your a value is still the same, it's 1. You get what I'm saying? So if you simplify this formula here, you'll divide by 2 everywhere. Right? So you're going to end up with x squared plus y squared equal to 9. Your a value is 1, your a value is what? So it's ax squared plus ay squared equal to 9 is what? It's 3 squared. So x squared plus y squared is equal to 3 squared. So your r is 3. And look at it in the graph. Your r is your radius, right? If you look at these points, how many is that? 3. If you come here, it's 3, right? So on your circle, your radius should be 3 throughout. Okay? You're done yet?
Yes.
Okay. Okay, now if they give you that what formula is it?
So
It's still a circle, right? It's that formula where you would say y is equal to the square root of r squared minus x squared. But remember, now it's only a positive. Right? It's not positive and negative, because they only gave you y is equal to positive square root of 9 minus x squared. Right? They never tell you plus minus. So when you're solving for this, for your x-intercept, you would let y equal to 0. So you would have said 0 is equal to the square root of 9 minus x squared. You would square the 0, which would become 0 equal to 9 minus x squared. Minus 9 is equal to minus x squared. 9 is equal to x squared. Whew. Then you square root here, right? But remember, they're telling you that y is equal to positive values, right? So this value that comes out, you will only take, no, I lied, sorry. You will still take positive and negative 3, right? Because it's the square root of this number. Your x values will be positive and negative, but they told you your y is equal to a positive number. Your x values you'll still calculate as normal, it will be a positive and negative. But because they're telling you here that y is equal to a positive of the square root of blah blah blah, right? So you would say now your y-intercept, let x equal to 0, right? So you would have said y is equal to the square root of 9 minus 0 squared. 0 squared is? So you're left with y is equal to the square root of 9. But remember what they gave you at the top? Y is equal to the positive value. So y would only be equal to positive 3, not plus minus 3. So when you're drawing your graph,
3 points.
okay, you only have 3 points. So the points you have is, so let's say this is 1, right? You have plus 3 and 0,
Minus 3.
right?
Yeah.
Plus 3 and 0, which just say plus 3 and 0 is here, minus 3 and 0, which is here, and 0 and 3, right? So when you're drawing your graph, it will look like that, okay? But if they told you y is equal to minus 16 minus x squared, right? It's still a similar form to how this is, right? But now what they're telling you, that y is equal to a negative value. So when you're solving for it, you'll do the same thing. X-intercept, let y equal to 0. You will say 0 is equal to minus square root of 16 squared. This divided by the negative side, right? It will be 0. You square the 0, it will still be 0. Is equal to 16 minus x squared. Minus 16 is equal to minus x squared. Then you would say square root of 16 is plus minus
4.
That's your values of x, right? Then y-intercept, you let x equal to 0. So you would have said 0 is equal to the negative square root of 16 minus x squared, right? You divide by the negative sign, it will be 0 still. You square the 0, it will still be 0. So this will be 0 is equal to 16 minus x. No, man. Hey, I want you to stop me to her. Just let me go. Right. Right.
Until the break, the break.
Y is equal
Give your
to
energy.
minus 0 squared?
0.
0, right? Then you're left to the minus square root of 16, right? But what they told you, okay, your y is a negative value, so your answer will be negative 4. So you only have 1 point of negative 4. So if you were drawing it here, right, your 2 points would have been minus 4 and 0 and 4 and 0, right? And the other point would have been 0 and minus 4. So this graph would have looked like that. I understand? But that's only if they give you the graph like that. You will only need to draw 1 point for y. Okay. Not bad so far. How are we doing? 10. Let's go.
Yeah.
Yeah.
He's never happy.
Should say that about him. We've done straight line, we've done ellipse, we did circle. Next we bring the rectangular hyperbola.
Let's see now.
Morning, how are you all?
Hello.
Well, you're braving the cold.
It's fine.
How are you, Jeff? You're alright?
Good.
Okay, alright.
So we had the straight line, but we had that, what's the
Ellipse.
Yeah, we had the ellipse, yeah. Yeah, the circle, and what do you call this one?
Circles.
Half circle.
It's the third formula I gave you under circle. See, I gave you the formula, I said O, and then I said O again. It's the
Okay.
it's a half circle. We only got one y value. But it just you more on the log graphs, the tan graphs,
We have an image, that's it.
trig graphs. Yeah, tomorrow we do log and exponential, we're going to trig. Thursday I finish on trig and parabolas. Then Friday I can do like how I did Monday's trig lesson, you know, past year paper question. Very good.
Yes.
Can you go? That's it.
Yeah.
This would be number 4. We got 3 already.
Yeah.
Yeah. Okay, this is the rectangular hyperbola, right? Now, remember from like school, hyperbolas, right? You normally would work out a point, you would have something called your asymptote, and just say if you have a line here, and if you worked out your point to be this and this, you would draw your hyperbola like that, and you would draw it like, I don't know, something like that, right? That's how your hyperbola would be drawn, okay? Now we're looking at something called a rectangular hyperbola, right? So they tell you here that the x and y axis are your asymptotes. So basically, remember your line would never cut your asymptote, and you'll have like a mirror image. But now in this instance here, your x, your y and x axes are your asymptotes, right? The position of the graph is determined by the sign C. So this value here,
Which page are you on, sorry?
I'm on page 141, right? So this value here, if it's a positive value, you will draw your hyperbolas in these quadrants. You'll see it in the next page, right? If it's a negative value, you will draw it in those quadrants, okay? And how you know where to plot your points? You would, so say for example you have x, y is equal to 4. Now looking at it now, we can tell by the general formula it's a rectangular hyperbola, right? And we know that the x and y axis are asymptotes, right? The sign is a positive value, so you would draw it there and there, right?
Okay.
Now where would you plot the center point of it? All you do, you would square root the number that's given to you, the C value. So if you square root it, it's going to give you
16.
2.
If you square root 4, it's going to give you 2, but it's going to give you plus 2 and minus 2. So your values that you will plot would be 1, 2, 1, 2, 1, 2, 1, 2, right? It would be, your one coordinate would be 2 and 2, because it will give you your one set of points would be the x and y value. So your positive would be x and y. Positive 2 would be x and y. Negative 2 would also be a x and y coordinate. So this would be another coordinate, and this coordinate would be negative 2 and negative 2. Understand? Yeah? And then you would just draw your hyperbola. Right? You okay with that? Okay. And if you were given example x and y equal to negative 4, right? Now what we said the positive and negative sign indicates? The quadrant in which is being drawn. That's a negative sign, so it will be drawn in this and this quadrant. How we get the point? We just square root the C value. Don't take into account the sign, because your sign is used to tell you your quadrant. So the square root of this would be, right? Actually, I lie, you do have to take into account the sign, right? But when you're drawing it, no, you don't need to take into account the sign, because you know that your intercept value will be 2 for your x and y, right? And you know the quadrants you are drawing it in, right? So the only values that you can get over here is negative 2 and 2. And here, 2 and negative 2. You get what I'm saying? Right? Because this negative sign told us that we can only draw it in there. Right? Square rooting the C value told us at what point your hyperbola is going to turn. Right? We can only draw it in these two quadrants. So you're going to end up with 1 negative, 1 positive, 1 negative, 1 positive value. Understand? You're sure you understand what I'm saying?
Because the x is positive, in the second quadrant the x is negative and the y is positive.
Yeah.
And the fourth side.
So this here would be, okay, this here would be, okay. Like for example, if you had xy is equal to -9, right? Xy equal to -9, the negative sign is telling you that it's going to be in the second and fourth quadrant, right? The square root of 9 would give you your turning points. So that would be 3. But now you will have to look at each axis. In your y-axis it would be +3. Here it would be -3. You would join the points and you would get your turning points with this axis. Here you would get 3 on your x-axis, -3 on your y-axis. And you would get your turning point. Are we okay with that?
Can you take me back from -2 and -2?
Yeah.
How is
Okay,
because
so
our xy is 4, right? That gives us the first quadrant. But for third quadrant, how we can
yeah, so this blue writing is for these graphs, right? And the purple writing is these ones. Okay, so from the rules, positive value of C is you'll draw it in the first and the third quadrant. And then
that's
negative.
a rule.
Yeah, that's a rule. If you get a positive value of C, first and third, negative value, second and fourth. And then that's it. So main thing for rectangular hyperbolas, your x and y axis are your asymptotes. And then if you have a positive C, first and third, negative C, second and fourth. This side I can take off.
Yeah.
Yes.
This will be number 5. Okay, let's do this one and then I can take it down after that. This one is the hyperbola, right? Different to the rectangular hyperbola because of this formula here, right? Now, this formula is basically x squared over a squared minus y squared over b squared is equal to 1. It's your intercept formula. General formula, cx squared minus dy squared is equal to e. You could have even said ax squared minus by squared is equal to c, right? But doesn't this formula look very similar to your ellipse formula?
Yes.
Your ellipse formula is what?
But it's positive. It's plus.
Right. That's the difference, the positive sign. Right? When you see the negative sign in between, you know that you're looking at a hyperbola. If you see the positive sign, it's going to be an ellipse. Okay? That's why they call it CDE, because they didn't want you all to mix it up with ax squared for the ellipse. Okay? So, now if they gave you 4x squared minus 9y squared equal to 36. Now this looks like that general formula. Yes? Okay. Now you say x-intercept, let y equal to 0. So you'll say 4x squared minus 9 times 0 squared is equal to 36. 4x squared is equal to 36, x squared is equal to 9, x is equal to plus minus 3. Right? Then y-intercept, let x equal to 0. So you would say 4 times 0 squared minus 9 times y squared equal to 36. This would be 0, so you're left with minus 9y squared equal to 36. You're left with y squared is equal to negative 4. What's going to happen? You're gonna square root here, is it? Square root of a negative number?
Positive.
No, square root of a negative number. There's no square root of a negative number. Square root of, if you put in your calculator, put square root of -4, and tell me at the error. Right? It's undefined. You don't get a square root of a negative number. Okay? So, this here is undefined. Which means what? There's no value for y. Which means that this is not going to cut the y-axis at any point. Okay? So, when you're drawing a graph, in this instance here, your x and y, your x and y axis will act as your asymptotes, right? It will separate these two. Actually, it won't act as your asymptote, but it will be your separating points between your right hand side and your left hand side. Okay, your asymptotes will be found at the gradient. We can work that out just now. But your 2 points you have is 3 and 0 and -3 and 0, right? And we got no y value. So this is -3, this is 3, right? Okay. Now, oh my god, I'm on the 6 over here. That would be 1. That would be another one, right? Now, if you had to make y the subject of the formula, that will give you your gradient. Now your gradients are basically your straight lines that, if you look at your diagram on page 143, right? Figure 530. See, we got y is equal to -3 over 2x. That's basically your asymptote lines, right? That will separate. So what they basically did was they took 4x squared minus 9y squared is equal to 36, right? So if I make y the subject of the formula, what's going to happen? I'm going to end up with minus 9y squared is equal to minus 4x squared plus 36, right? Then I'm going to end up with divided by the negative sign, 9y squared is equal to 4x squared minus 36 divided by 9. Y squared is equal to 2 over 3 x squared minus 4. Right? Square root, I'm going to end up with y is equal to 2 over 3 x square root of a negative number? Undefined. So what will happen there? It's going to fall away. So this is going to be one equation for the asymptote. But the square root of 2 over 3 is going to be a plus minus number. Okay? So your gradients, remember this is what now? What type of equation is it?
Linear.
Straight line linear equation. Right? Okay, we already draw a hyperbola, right? But we need to know how far we can draw these lines. Because why didn't I draw the line like this or something? Right? So that's where your asymptotes come into play. So now we got the equation for our asymptotes. Yes? If I substitute 0, okay, so I got y is equal to plus 2 over 3, I got y is equal to minus 2 over 3 x. Right? Your asymptote line, if you look at the diagram, is what? It's a straight line. Yes? Yes. If I substitute 0 for x here, your y value is?
0.
It's going to be 2 over 3.
Multiply
If you put
by
no, it's going to be 0.
Right.
Yeah.
And if I substitute 0 here? 0. Substitute 0 here?
0.
And here?
0.
0, right? But what I told you about these lines, if it's a positive line, how does it slope?
First and then
second to fourth.
The?
first and third.
Not first to third, but it slopes like that, right? If it's a positive gradient. So your gradient, your asymptote line, oh shit. Let's pretend I can join, right? That's your one asymptote. Not cutting any x values, not cutting any y values. Where it cuts it at? 0 and 0. But because it's a positive gradient, I drew my asymptote like that. Yes? Yes. the negative asymptote, that would look like that. Right? So when I'm drawing these, I can draw it, okay, it's not to scale, but I can draw it as close as I can to that for a value of 3 here, and that should be the graph that you will draw.
Can I please take you back
To it.
just to give a quick recap of gradients and asymptotes?
Okay, so can I take all this off?
Yeah.
Not all of this, but like all of this.
Yeah.
Okay. And can I take out? Can I take out this?
We never take it down.
Huh?
Oh, we took it down.
That's
That's
okay.
about it.
Yeah, take a picture of it. Okay, right? Now remember, for hyperbola, right? You need to basically work out the points, your x and y points, right? Then you need to obviously have your asymptotes because you need to know how much you are drawing your curve. Like if you look at the diagram here, they have the x and y, the x values, right? The y value we worked out is undefined, so this graph won't cut the y at any point. Okay? Now we need to know our asymptotes because we need to know how close we can draw this graph. So, asymptotes, you will basically convert this into a linear equation. Okay? So, your asymptotes. And how you convert it to a linear equation, you would say, you would try to get it in the form y is equal to mx plus c. Right? So, how I got that there was, I said 4x squared minus 9y squared is equal to 36. That's our hyperbola equation. Right? I want to convert it into a straight line equation, so I'm going to make y the subject of the formula. Right? So I'm going to say minus 9y squared is equal to minus 4x squared plus 36. Okay. Right. Divide by the negative sign. 9y squared is equal to 4x squared minus 36. Divide by the 9. Y squared is equal to 4 over 9 is 2 over 3. Right? 2 over 3 x squared minus 4. Now I want to get rid of the y squared. So what I'm going to do? Square root it. Right? So you're going to square root each term. So I'm going to square root 2 over 3x squared minus 4. Right? But remember this is all one term. So what will happen? Y will be equal to 2 over 3x. Yes? Understand that? And then square root of negative 4 undefined, so there will be nothing else. But this value here is going to be a positive and a negative value. So our one asymptote is y is equal to positive 2 over 3x and y is equal to negative 2 over 3x. Right? Now for any other hyperbola equation, we would substitute a value for x and y to get points. Now remember your asymptote lines are straight lines. So we need to show it. Right? How you would get where the straight line is, you substitute 0 to get your y-intercept and you substitute 0 here to get your x-intercept. But what we realize is when we substituted 0, the points are found at 0 and 0. So your asymptotes are basically cutting at 0. Do you understand that? Okay, so to get the asymptote, make this equation into a straight line equation. To get the asymptote. So how you would do that, you would say, you need to get in the form y is equal to mx plus c. Okay, now how do we know how to draw it? Right, because it's just basically cutting at 0. What is it, right? This will be your graph, right? So you would start off by drawing your asymptote. So if this is 1, 2, 3, this is 1, 2, 3, 1, 2, 3, 2, 3. Right? Your y-axis, x-axis, 3, minus 1, minus 2, minus 3. Okay, start with drawing your asymptotes first. Right? Now, we know your asymptote cuts at what point? 0 and 0. Your gradient. Remember in straight lines, if it's a positive gradient, it looks something like that. If it's a negative gradient, it looks like that, right? So your one asymptote would look like this. So this is y is equal to positive 2 over 3x. Yes? And your other one would look like this is y is equal to negative 2 over 3x. So now we know where our boundaries for our hyperbola is. Because there's no y value, you wouldn't expect it to cut it at any y value. The x-intercepts of our hyperbola is this, 3 and minus 3. So now when you're drawing it, you'll draw your line as close to this as possible, and you will look like that. Do you understand what I did? Okay, so first thing we did was we looked at the equation they gave you. Looking at it and looking at our general formula, we know that it's a hyperbola, right? We solve for your values of x. Now see, these are things now with each type of equation that you need to know. For hyperbola, you need to have an asymptote and you need to have your intercepts, right? Your intercepts will basically be the turning point for where these lines will basically turn. So you will draw it as close to your asymptote. You will come towards the point, and it will obviously turn in the other direction at that point. Yes? Right. So we worked on our x and y values. We found out that it doesn't cut the y axis at any point. That's fine, right? Once we get these values, you will work out your asymptote. Now, how you work out your asymptote? You will try to make this, you will make this into a straight line equation. How would you do that? You will make y the subject of the formula. To get it into the form, so you will say y is equal to mx plus c, right? So that's general making subject of the formula, which is what I did here. Came to this point here. Now we know that these here are two straight line equations. So your asymptote is also a straight line equation. Yes?
Yes.
So to know where you would draw it, you would substitute a value, you would calculate intercepts and you would draw it. But we know that it's 0 and 0, 0 and 0, and because it's a positive gradient, this would look like that, negative gradient, that would look like that, and you would draw your hyperbola in between those. Understand? Can go and practice it, do a bit more examples. This is where I'm stopping for today. We've looked at 5 different types of graphs. We've looked at the straight line graph, we've looked at the ellipse, we've looked at the circular graph, we've looked at a rectangular hyperbola, and we've looked at a hyperbola. Tomorrow we're going to look at log or exponential graphs. We should finish that, so we look at some of the trig graphs, and then on Thursday we will finish trig graphs and parabola, and we will be done with graphs. Okay? So far it's not bad. Any questions?
So when we're doing that, going back on the rectangular graph, we didn't have any asymptotes.
Because your x and y axis, remember I told you the condition that your x and y axis acts as your asymptote.
Okay.
So that would be your asymptote, and then you just draw it in the quadrant. So you'll draw it as close to your x and y axis as you can.
On the rectangular hyperbola, students would draw this asymptotes.
No, no, you don't have to. What do you see that line they're showing that way it's coming through? They say y is equal to x. It's basically your turning points on those ones should cut each other because of the way the graph general form is.